Okay, so now that we're done with learning concepts in Chapter 10, we are going to end with some application problems. And in this video, we're going to focus on compound interest. So compound interest is where let's say you put $20 in the bank and you invest it in the bank, and then let's say that you are earning a 10% interest rate, which would be awesome. So 10% as a decimal would be 0.10. So if you start with $20 and then we multiply, you're going to make 10%. So if we have 20 times 10%, we would make $2 in the first year. So now our $20 is not $20. Now we have an additional $2 in the bank. And so what compound interest is, then in the next year, it's not going to use the $20. We're going to leave that $2 in, and now we're going to have $22 in. So now in the next year, we're going to have $22 and earning 10%. And now instead of $2, we earn an extra 20 cents. Now you may think that that's not a lot, but over the course of time, this is going to grow to more than just the 20 cents, and it's going to make it worth it. So now we've made $2.20. So now we're going to have $24.20. So we're going to have even more money, and so on. So the point is, compound interest is this formula right here, and it is used when you make interest, and then your interest is going to make you more money because you're going to leave that interest in the account. So just to demonstrate how to use this formula, I just did the math and showed it here, but if I wanted to use this formula for when the values get a lot larger, so the A represents the amount you're going to have at the end of the year. The P represents how much do you start with. So we started with $20. The 1 represents that whole 20. And then we're going to add to our money 10%. So the R represents the percentage as a decimal. And then you're going to divide by how many times is this going to happen. So if it only happened once, we're not going to have this be monthly or something like that. So our N is how many times, we're only doing it once. So then our formula says to take N, which is we're only doing it once a year, and then multiply for how many years. So if we did this for 2 years and we want to see does this formula work, we're going to put 2 to see if we get this end amount here. So again, if our N was that they were going to pay out monthly, we would put 12 here. If it was semi-annually, we put 2. So that's what the N represents in the formula. So we're going to go ahead and do parentheses first in order of operations. So 1 plus 0.10. Then in order of operations, we do exponents. So raised to the second power. And then multiply last. So then multiply by 20. And we get $24.20, which is what we got here. So again, the formula for compound interest, that's a visual of what this formula is doing. It's keeping an account that you're not going to have $20 anymore because you're going to keep your interest in there, and it's going to keep growing and growing. Okay, so let's write down some of that stuff that we just talked about there. So compound interest formula determines the amount of money A, so A is your amount of money, that will be in the account after if P dollars, so P is how much you're going to start with, and then T is how many years, so it's always in years. And then your annual interest rate, so your rate is R, and you need to write it as a decimal, so as decimal when you use the formula, and then compounded N times. So just to practice a little bit, if N was yearly, N would be 1, like the example I did with the $20. If it was semi-annually, N would be 2, just like semi-annual sales happen twice a year. If it was monthly, we would use 12 for N. If it was daily, we would use 365 for N. If it was weekly, our N value would be there's 52 weeks in a year. So those are the common ones that you'll probably see. And that's how you would know, depending on what the problem says, what to use for N. So let's go ahead and take a look at example 1. It says Sandra invests $5,000. So that's how much she invests. So she starts, so that's our P, $5,000, in a savings account that pays 5%. So that's our rate, 5%, but we have to convert it to a decimal. So we would, to change a percent to a decimal, we would get rid of the percent and move the decimal 2 to the left. So it'd be 0.05. Compounded quarterly. Ooh, I forgot that one. Let's add that one to our list. So quarterly means 4 times a year. So N would be 4. Just like there's 4 quarters in a dollar. That's how I remember it. So our N is 4. And it says to determine the amount of money she will have in the account at the end of 3 years. So our T would be 3. That would be our time. So then we would take our formula here, and we're going to go ahead and substitute our values. So we start with $5,000. We're going to take that whole amount, and our interest rate is 0.05, and it's going to be divided 4 times in that year. And then N is 4, and our years is 3. So now when we simplify this equation here, we need to start with the parentheses first. And inside the parentheses, we start with the division inside, because division comes before addition. So we're going to have 0.05 divided by 4, which is 0.0125, and then add 1 to it. So add 1. And then after parentheses, we do exponents. So 4 times 3 is 12. I'm going to bring down the rest of the problem. Then we do, after parentheses, we do exponents next. So exponents would be next. So we're going to have 1.0125 raised to the 12th power. And we would get 1.1607. And I'm going to put ... because there's more numbers. I'm not going to write them all out, but I need to leave them in my calculator screen. I don't want to clear this out. And then I'm going to bring down my 5,000, and I'm going to multiply by 5,000. And then click equal. Now if we read the directions here, it says round your final answers to the hundredths place. So hundredths has 2 zeros, so that's how I remember if I want the hundredths place, I need 2 decimals. Okay, so hundredths place, we want 2 decimals, but we always have to go to 1 extra and see if this is 5 or higher, which it's not. So it's about $5,803.77 that would be in Sandra's account at the end of 3 years. So again, this is how I would write my answer. This is how I would write my answer in a sentence. The amount in Sandra's saving account at 3 years is about $5,803.77.